So this is another example about a second order homogeneous equation, but this is slightly different because of what? Because I have this one. So on your right side, this is called the initial conditions. So we're going to use this initial condition to do some further step. So the idea is still the same here, but I only have some extra step on the below this one, step number 4. I'm going to get some constant back, like the a and b values for the constants. So this is the next step. So we have this equation. Basically, we're going to solve the first ODE first, the ODE equation. So I just transform this one to the second order ODE, which means this one I become the m squared, and this one they become m, and this one constant, they become 1. And so this is what I have here. So once I have this, I'm going to solve for the quadratic equation. Because of this, I need to use the formula, and this is what I get here. So this is the real and distinct roots, and because of real and distinct root, I can just refer back to the table that I have here, and then so this is what I get here. Because this is my m1, this is my m1, this is my m2. So this is my general solution. So the next step is I'm going to get the value for a and b. So how to get the a and b? Actually, it's based on the initial condition that you have here. So this is your initial condition based on the question that you have here. So y 0 equals to 0 is means by when your x equals to 0, your y equals to 0. And the same thing for y prime 0 equals to sub 3, actually is equals to when your x equals to 0, your y prime equals to sub 3. So this is what that means. So when you have that, so you're going to using these two informations to get the value for a and b. So what I can do here for this one, I'm going to differentiate this one for one time I get for the y prime. So differentiate this one, of course it's very easy. I get this one, and differentiate this one, I get for this one. So once I have this, I'm going to substitute the first condition to this equation and the second condition to second equation for this one, because this is also another reason why I need to differentiate this equation to get a y prime, because I can use this one to substitute in this equation. So this is the first initial condition I use. I substitute to the original solution, the general solution, and I will get some relationship, something like a plus b equals to 0. And the same thing I here, y prime 0, so I just substitute into the equation that I differentiate just now, and then so this is what I have here. So I'm going to substitute the x equals 0, so that means exponent 0 is 1, and then this one b0, so the exponent 0 here become 1, so this is what I have here. So I have one equation, second equation, so I can solve this equation simultaneously, and this is what I make the relationship like this one. So I get the value for a, which is equals to 1 over 2, then b equals to -2. So this is my general solutions. Okay, so this is general solution, and then this is the value later. So this value a and b, you're going to replace here and replace here, and you get the solution.